All right, somebody stole my cupcakes, and I'm not going to let this drop. So we're going to science this thing up and see if we can't figure out who did this. Today, I want to take a little bit closer look at some of these clues. In order to understand what's going on with some of this stuff, we need to look at some of the properties of those materials. The properties are things that make the material what the material is. Now, there are actually two different types of properties. If I take a look at paper, for example, you'll see that if we make some observations about these three different sheets of paper, they all appear to be about the same size. They all appear to be made out of similar paper. They have the same texture. And they kind of have the same feel, the same weight on them. But what's different about these pieces of paper is the color. Now, color here is actually known as what's called an extrinsic property. Extrinsic kind of means on the outside. It's not a term that you really need to know, but it's something that is has to do with what the paper is like when you look at it. For instance, I have a piece of paper here, which is a fairly decent size. If I fold it in half, we still have a piece of paper, but the property of it is that it is actually a little smaller. If I cut the sheet of paper or rip the sheet of paper, now I have a smaller sheet of paper. But you know what? It's still the same paper. These things that are on the outside, or doesn't have to do with the fact that it's actually this piece of paper, are called extrinsic properties. And that really isn't going to help me too much in my investigation. Some of the extrinsic properties that we want to look at in terms of, this foil here. The foil here in this cupcake holder is shiny. The color or the shine of it is an extrinsic property. It's kind of on the outside, where this one is not. This one is definitely orange. So these types of properties, things like color, texture, where they're located, shape. We have these shapes, but I can make this thing any shape that I want. Shape is all kind of stuff that I can do to the paper. It doesn't really have anything to do with what the paper actually is. For that, we need to talk about a different type, which is called intrinsic properties. I've got three different pieces of wood here, all with different properties. And I want to talk about what are those different properties here. If we see, I've got a little wooden ball right here. I've got a big piece of wood here, and then I got a giant kind of bigger piece of wood here. These all have different properties. Now, we can talk about some extrinsic properties of these, some outside properties. The shape of this little ball is much smaller than this, and definitely smaller than this. The mass of this ball. Mass means how much stuff is actually there, how big it is, or how much stuff is actually in that you're talking about. And since this is smaller, it's probably going to have less stuff than this piece of wood or this piece of wood. And I say probably, we'll see that in a minute. These are all things, the shape, the size, all those things doesn't have anything to do with the type of piece of wood. In fact, these pieces of wood are actually different types of wood. There's oak and cherry wood and probably an elm type of wood. So those are different types of wood. Now, how do I know which is which? Well, we can't compare the weight of them. We can't compare the mass of them because this is just a bigger piece of wood. But what if I could take this wood and carve it into a small ball like this? And take this piece of wood and carve it into the small ball like this? Would they be identical? Let's think about that for a minute. So here I have three small balls that are all the same size. I've got the wooden ball that I made, and I did this with different materials just to kind of give you a better understanding than just the piece of wood. I didn't know how to get the piece of wood this way, but I do have this wooden ball right here. I also have a aluminum ball right here that is the same size, and I got a brass ball right here that's also the same size. Now we can see externally that these are not identical. The wood ball has a different color than the aluminum, which has a different color than the brass. But there's also some other things that are different intrinsically, inside, that makes brass different than aluminum, which is different than wood. And one of the things that makes these different is something called density. Now these are all three the exact same size. Does that mean they're going to weigh the same? Will a wooden ball that's this big weigh the same as a brass ball that's the same size? Let's find out. I've got a balance right here that we can look at and see if these things actually weigh the same. I'm going to put the wooden ball on this side, and you'll see that the tray moves down this way. My little arrow moves that way. If I put this one on here, if the balance evens out, then they weigh the same. But let's see what happens. Oh, the balance actually really turned this direction. This brass ball is a lot heavier than the wooden ball. What about the aluminum ball? The aluminum ball, if I put it on here, oh, it's also heavier than the wooden ball. What about the aluminum and the brass? So now I got aluminum over here. I'll put the aluminum there, and I'll put the brass on this side. Oh, the brass is heavier. These definitely have different masses. They have different amount of stuff. Even though they're the same size, even though the volume is the same. Volume we talk about as the amount of space an object takes up. Even though the volume is the same, they have different masses. There's more stuff. We consider mass to be stuff. There's more matter. There's more stuff. There's more mass inside this brass ball than there is in this wooden ball. We call the amount of matter stuck inside something, we call that density. We would say that this brass ball is more dense than the wooden ball. Density meaning it has more mass packed into a smaller area, or in this case, the same size area. Let's take another look at something else that has to do with density. Another property that's pretty important in my evidence here has to do with something called solubility. I have some water here in this flask. And you can see there's nothing that we can see inside the water, so it's not that big of a deal. But what happens if I put something in the water? If I put some sugar, I got some sugar, and I'm just going to take a little pinch of sugar and put that into the water. And I can see that there are some sugar crystals in there. And if I kind of roll that around a little bit, I will find that my sugar crystals actually disappear. Now that's actually called solubility. That's actually, we say that the crystals have dissolved in the water. Dissolve means that the atoms that make up the water, the little tiny atoms that make up the water, we are kind of moving around, and they're kind of rolling around like this, and then we put sugar in there. And that sugar actually takes the place, goes in between those molecules of water. So they can fit in there, and they kind of disappear because molecules and atoms are really, really, really small. And so I can see that there's not a lot, I can't see the sugar anymore. The sugar is still there, however. If I were to drink this, it would kind of taste a bit like sugar water. Let me show you a bit of an example on how this is with a model and see if we can't figure out how this works. All right, we can imagine this water. This water is a liquid. And in the liquid, there are tiny little molecules of water, little H2O molecules that are sitting around. These molecules are free to move in and out of each other. If we model this, we can show this with some ping pong balls. I've got these ping pong balls in here. Each ping pong ball we can consider to be a water molecule. And if I kind of shake this around, those ping pong balls actually move around each other. We call that a liquid. They're still bound by gravity to the bottom of the container, which is a liquid. If they are going so fast that they bounce out of the container, like that, we would call that a gas. This thing goes flying around the room. And if they're just sitting there and vibrating like this, we would call that a solid. But they're a liquid. So they're moving around the container like this. That's what's happening in the water. Now what happens when I add the sugar? If I take a sugar molecule, let's say it's something like this, and put it in the water, those water molecules have enough space to get out of the way and allow that sugar molecule to sit in there. So that sugar molecule is going to spread out. If I put a couple of these in here, they can fill the spaces, fill the gaps between those water molecules. We call that dissolving. And they somewhat disappear. The crystals break apart, and those atoms can now move around in the gaps between the water molecules. But what happens if I add more sugar? If I add more sugar, well, they just start to fill up more gaps, don't they? And I can add a whole bunch of sugar here, and they can still fill up the gaps between those water molecules. But if I add even more, we are going to get to a point where all of those gaps between the molecules are full. And now the sugar can't fit inside those water gaps. And we're actually it's not going to be able to break apart, and we're going to be able to see the sugar. This is called saturated. Saturated means I have filled all of the gaps between those water molecules, and the sugar will no longer dissolve, will no longer break apart in the water. Let's see what that looks like in real life. So here I've got my sugar, or my water right here. And what I'm going to do is I'm going to put a little bit of sugar in there. So let me put a little funnel on here. I'm going to put a little bit of sugar inside there. So you can see those sugar crystals are actually inside the water. And let me roll this around a little bit, and we'll see if we can't get these guys to dissolve in there. Are we saturated yet? Well, it looks to me like most of those crystals are starting to disappear. There's still some at the bottom there. Can I get them to break apart? Oh, it looks like I can. I have got all of those crystals are now gone. So I'm not saturated yet. I can put more sugar in this. Well, let's try it. Let's put more sugar in, see what happens. Put a lot in, see if we can get this to saturate here. All right, so now I've put a whole bunch of sugar at the bottom. It's just like placing a bunch of those colored balls in with my ping pong balls. And let's see if we can't get this to disappear. All right, a lot of it is gone, honestly. A lot of it is gone. It looks like there is a little bit left at the bottom of this container. You can dissolve a lot of sugar in water. So even those, I'm at 3 spoonfuls right here. And still, almost all of it is gone. And if I give this enough time, all of that's probably going to be gone. So we're still not saturated yet. I think we can fix that. All right, I got a lot of sugar in there now. If you've ever made Kool-Aid and put too much sugar in it, you'll find that you're going to get this exact same phenomenon. So it doesn't look to me, I mean, it looks pretty white now. It's no longer clear. And if we wait and take a look at what this looks like in just a minute, I can see at the very bottom, there are still those sugar crystals that are sitting there. So let's give this just a minute to kind of relax. Oh, you can already see it. You can see the sugar starting to fall towards the bottom of the container. So there is definitely kind of a goop of sugar at the bottom. That's actually still sugar crystals. They didn't dissolve in the water. So you can see at the bottom, there's still a lot of sugar in there that did not dissolve. So this would be considered saturated. We've put so much in there that it will not break apart and dissolve in the water. So we can see that the sugar, after a little while, is actually stuck on the bottom. Now it took us about 4 spoonfuls of sugar in order to get that to happen. We would say that sugar is very soluble. But what about other things? So here I've got some more water, same kind of deal, but I've got some baking soda. Is baking soda, does it dissolve in water? And does it dissolve as well? Well, let's find out. I'm going to go with 1 spoonful here of baking soda in my water. So this is 1 spoonful. And let's see what we can find. Well, it looks like it is dissolving a little bit, but also the water is very clear, is very white. So if we give this some time, and I can see at the bottom that there is still baking soda sitting at the bottom, this is already saturated with 1 spoonful. So we would say that sugar dissolves in water better than baking soda. So if I had a white substance that could be one of these 2 things, what I could do is I could figure out, does it dissolve in water? And how good does it dissolve in water? If it dissolves really, really well, it might be sugar. If it doesn't dissolve quite as well, see we've got baking soda sitting at the bottom of this thing. If it doesn't dissolve quite as well, it might be baking soda. So this is a way we can tell. If I didn't know that this was baking soda and I didn't know that this was sugar, we can look at an intrinsic property, how well it dissolves, to figure out what it is. So you guys have done some activities with M&Ms. When you put the M&M in the water, the dye from the M&M dissolved into the water. And we were able to figure out, are all of those dyes the same? Did they all dissolve at the same rate? So yesterday you should have figured out which M&M colors go faster, which ones go slower, or do they all go the same? And I think this is one of the ways we can determine which is by how quickly they dissolve, how quickly those molecules, those big molecules, can move through the water and spread out. Tomorrow, we're going to do some more activities with those M&Ms. We're going to take those M&Ms and we're going to start to figure out what happens if I start doing stuff to the water. What happens if I get warmer water or cooler water? What happens if I already have sugar in the water? And then, so there's other things that those little molecules have to compete with as they spread out through the water. So moving forward, I want you to start using some of this vocabulary that we've learned. We learned about mass. We learned about density. We learned about dissolving. We learned about saturation. All of these things can be used to describe what happens with these M&Ms tomorrow. Have a lot of fun, and I'll see you next time.